visual topic because we all work on the back end. We don't visualize anything, so we have other people do it for us. And this will be in the context of the data frame kind of data structure, because data frame is uniquely suited for creating charts, because you already have everything in a table. So if you may remember, I don't know how many people were here last month when Vladimir was presenting data frame EC. So DFLib that I will use as an example here is another open source data frame library, but both are this represent the same idea, which is very versatile, useful data structure that is a table, and you can do all the fun stuff you can do with tables elsewhere. You can do joins and all other good things. But among them is theoretical ease of visualization, because you already have your data in columns, they're aligned, so like you can put them on a chart. I'm not only the author of DFLib, I'm also a user of DFLib. So I'm using it for data analytics, for production code, for any like ad hoc kind of data tasks. And more and more, when I was using DFLib, like I discovered that I want a chart. I want something visual. I want to see how this data actually looks like. And maybe when I'm exploring a data set, I want to see the dependencies. I want to see trends. And also my users want to see some charts, based on the data that I create for them. So unfortunately, in Java, since 10 or 15 years ago, we all moved to the back end, and we gave front end to other people. JavaFX notwithstanding, all the libraries that were created for kind of charting in Java, they're showing their age, so they're not maintained, they're not very nice, and I couldn't find like a good library that compares to something like this. And so Apache eCharts is just one of the packages available to create charts in JavaScript, not in Java. There are other visualization libraries, but I'm using this one. But there's at least a few that are very high quality, very visual, colorful, and so on. So this slide doesn't even fit all the options that they provide. So if you go to like Apache eCharts, whatever, eCharts.apache.com, and look at in the example section, there'll be like pages and pages and pages of all this like colorful charts. So how do we make JavaScript work from Java? And this was a task I tried to solve within the DFLib library. So we already have a data frame. So how do we make it visual? And the idea was that, okay, so we can use JavaScript in the browser. And usually we see our presentations in the browser, so we can actually build a Java API to generate the JavaScript. So what we did in DFLib project, we created an API that looks kind of similar to Apache eCharts, but it's in Java, and the end result of that is like a block of JavaScript that you can send either as a REST endpoint, or I will show you how to just play with data in Jupyter Notebook. Okay, so next on the demo. So what I have here, it's Jupyter Notebook. I know it's not seen for a Java developer, because usually people like who are programming in Python, they're using that environment. But that's essentially a visual environment, not unlike JShell, for instance, where you can actually run some Java commands, and it's no different from Java. So all this code can be then copied and pasted into an application. And Jupyter probably requires its own talk. So this talk is about visualization, not about Jupyter. But like here, I'm running regular Java code that can be used anywhere else. So let's do some visualizations. I'll be starting with a data set that is just stock prices that I got from Yahoo Finance for Apple. So first thing I need to do is to load that from a CSV that I have on my drive. But you can obtain data in any way you want. And of course, I need to create a data frame. So our first data frame will be Apple stock, and it's coming from CSV, not CVS. And we just load a file from my local file system. Oops. And Jupyter is very visual even without charts. So in the last line, I'm putting the name of the variable, and the last statement essentially it's going to be rendered in the browser. So it renders this a variable, and this is the contents of the CSV just presented as a data frame object. So very simple, just one liner to get a CSV into an object, and this already can be visualized. So any column, so like we have a date and we have some values for each date. So let's visualize the stock price. So it's going to be date versus closing price here. So let's start with. So just like here, we started with CSV. To load a CSV to create an e-chart, we start with e-charts, and there's a factory method called chart, and we can tell it that the x-axis will be taken from the date column. So I'm building the structure of the chart. And instead of specifying the y-axis, I'm telling where the data is going to be coming from. So essentially, I can add one or more series objects. So I'm adding a series, and the series has a series opts. Series ops parameter, and here I can specify the type of series. It can be a line, a bar. So let's do scatter. And the second argument is the name of the column where the values are. And finally, we need to, so this is the definition of a chart. And finally, we can plot it, and we pass a data frame. So we pass a data frame, and this should work. So you see, like in just a couple lines of code out of our CSV, out of this tabular structure, I got a nice chart. It's a little blurry because I used scatter plot. I should probably switch to line. It'll be a little sharper. So the next thing I wanted to show is, okay, so let's make it a little more complex, more interesting. Let's compare, Apple stock to something else, to like another CSV that I have is Microsoft. So let's compare Apple to Microsoft, and so MSFT. So I load another data frame. So that's Microsoft stock price in the same date range. And since I can only plot multiple columns from a single data frame, and now I have the two data frames. I have A and I have M. Let's combine them. So data frame is very versatile, so you can just produce a join, for instance. So let's join them together. So the next, and produce yet another data frame. So here I'm just using a var. And let me assign aliases to the columns. So because we're joining two similarly structured data frames. So A as A, and then we do join. M as M. So the columns will be prefixed with this prefix, and we will join on date. So the date column should be the same in both, and we can do select, and this will produce another data frame. You see, just sort of like combine the data frame like this. Only it's a bit unreadable, and also the column names they have they may help us to build like a legend for our chart. So let's actually just narrow it down just for our own sanity. Just select the columns that we're going to plot, and also rename them so that the names are actually meaningful on the chart. And for this, I can just tweak the join a little bit. So I can specify which columns I want to include in the result from the join. So not all of them, just some. So A date, I want to be there. A close. I don't want M date because it's the same as A date. We joined on it. So we just do M close. Okay, so we have a much nicer data frame now. And let's also assign better names to the columns. So I can, instead of select, I can do select as and rename the columns. So I can rename it to date. I can rename it to Apple's ticker, and to the Microsoft one. Okay, so this is our data preparation for the chart that's going to have both Apple and Microsoft. And now I can take this chart and create another one. So here the column is called date, and series, let's use line instead of scatter. And here we will use AAPL, and we will add another series. So we can, oops, we can MSFT. I think I have everything. Okay, date. Oh, because I plotted the wrong one. So instead of A, I need to plot P. So I plotted the wrong data frame. And here are the here are the both stock price lines. And as you see, I don't need to select the colors or anything. eCharts picks it for me. So it creates all these nice things like out of the box, and of course you can customize it further. But the point, the good thing about it, you don't have to. Like, okay, looking at this chart, can we tell which one is Apple, which one is Microsoft? Obviously, we can't. So let's add a legend. So you can actually add lots of things to the chart. So now we have Apple and Microsoft here. And you can add a lot of other things. I don't have time. So like all the interactivity where you can actually zoom in, and like you can add like a toolbar that allows you to interact with the chart, download the image and stuff like that. I'm sorry? Is there a tutorial? I mean, so it's all in the it's all in the DFLib docs. But since the data frame part, sorry, the eChart part is actually like evolving pretty quickly. So some things are missing there, but essentially yes. So there will be in the DFLib docs, there will be a chapter where that shows you how to create a chart. It won't show you every single option, but it will show you how it works, and then you can investigate, like for instance, like here, like serious ops, like what type of charts do I have, so you can actually see what methods are available in addition to this one. And we are working on more documentation. Well,
now you can speak.
Without it also I'm loud, but okay. Do you have to do any initial setup for it, or you just need a notebook, a Jupyter notebook, and then like
yeah, so setting up Jupyter, if you want to specifically stay in the Jupyter environment, then yes, I mean you will need to set up Jupyter on your machine, install Java kernel, which is also like that's another thing that probably warrants its own talk. But we took a kernel iJava that was popular 5 years ago, and like the guy who maintained it, he disappeared, and so there was no commit since 2019. So we forked that, got it into our own namespace, and we maintain it. So we fixed all the bugs, and like my life became much better. So and we release it as we call it JJava. So it's a kernel, so you install it inside Jupyter, and then that's it. I mean, you can start using it.
Just find JJava on JJava on GitHub.
Yeah, so it's under DFLib. So DFLib organization has like multiple projects. One of them is JJava.
Excellent.
Yeah, and Barry, I think I saw your question somewhere in the iJava, maybe in the iJava GitHub.
Right. Been waiting for it for a long time.
Yeah, so essentially right now, if you have any complaints, you go to me.
I have all kinds of complaints, but they have nothing to do with Java or you.
Okay. All right. So and I wanted to show one more chart. So essentially, like, okay, so we can overlay the stock prices with trading volume. So here we can add a few more columns, and I know I'm taking a little more time, but hopefully we still have a few minutes. So we're going to add volume columns and call them something, I don't know, Apple volume, MSFT volume V. Okay, so we can render that. So two new columns appeared there. So, and this is the beauty of Jupyter. So I just like I had this variable A, now it's something else. So like I was missing those columns, I added them, now they're available. And with this chart, I'm actually do another one. I can add two more series, and they're usually like volume is usually represented as bar charts. Of bar PLV. So I can do this. And you see I have bar charts, but my prices disappeared because we are, different scale. So the volume is in millions, and the prices are in hundreds. So we can resolve that quickly by adding a second y-axis. Okay. So we can add another y-axis, two y-axis essentially. We declare one explicitly, one axis of value, and do another y-axis also of value, because we're going to plot value, and we put it on the right, and we move this bar charts to that other axis, non-default one. And everything is almost nice. I mean, things are, the millions are still like cut out, so we can spend more time formatting. I don't have this time, but essentially we have like different themes on the same chart, and it took us just a couple of minutes to write. So this is a presentation, and if you liked what you saw, you can give us a star on GitHub for DFLib, and please go to Apache Charts and give them a star as well. Yep.
And we'll just leave it in presentation mode, or not presentation mode. At Johns Hopkins University Applied Physics Lab, we have a bunch of sectors that do different things. And I work in a particular sector in a group that focuses on live data analytics and a heavy emphasis on applied machine learning research. And a lot of our stuff is translating information from various spigots and sources. And we have probably a 50-50 mix of Java and Python based development. A lot of data scientists and analysts, and a lot of knuckle dragging software engineers like myself who are really just good at firing software bullets. And so we put those two together and make some pretty cool stuff. So we have a lot of course, Python and Jupyter Notebook wrangling, and we have a lot of Java and Kotlin based capability that we've built up. I'm going to show some of it. So what's so great about the internet, everyone? Don't answer that. The internet's great, but let me give you one work-safe reason. The internet is great because it allows anyone, virtually anyone, to share virtually any information and spread it with a geometric rate at almost no cost. And that has the great effect of breaking down barriers and reducing control by authoritarian regimes and spreading freedom of thought. But don't answer this. What is bad about the internet? The same friggin' thing, right? But why? There are a lot of morons out there. You invited one to speak, I'm here. But there's a new problem, and that is that a lot of content can be produced for almost nothing using AI. Now, most of the people in this room, if you came here, you probably already understand that. But what you may not know is that the rate, according to some intelligence releases that are unclassified, the rate of AI-generated content on the internet is increasing at a hyperbolic rate year over year. So 3 digits worth of increase in percentage each year. And it's not going to stop. In another year, maybe 2, there won't be an internet. Because what it will be is just an exchange of information generated by bots for bots. And then what's going to happen is, because we don't know what's actually true and what's not, and it's already happening, we're going to retreat to enclaves that we can trust. Who's going to control those enclaves? Governments, municipalities, corporations. And they are going to say what's true and what's not, just like now. And goodbye, internet. Goodbye, freedom. Goodbye, freedom of thought. That's it. Game over. And the worst part is, like a dead, hulking whale rolling onto the beach, we won't even know as a society that we've lost that for a couple more years after that. And then it's too late. So what are you going to do about it? You can't stop them. Genie's out of the bottle, right? And by the way, I'm not up here to say that you should all go home and kiss your spouse and buy a cabin in the mountains in Chile. What I'm saying is And I'm also not saying that I hate AI. We have a lot of great use cases. What I'm saying is there's a lot of bad people out there, most of the people in the back right, that they maybe them too, they don't care about their ramifications. They care about getting paid next week. So what can we do about this? We need to make it so that the cost to use these things effectively is not worth it. Make the juice not worth the squeeze. How do you do that? You make it first steps first. Detect, defend, destroy. That's what you do in any war scenario. And we're at war with these people because they're coming for what you value the most. Okay? This is not my employer saying this. This is my paranoid personal being saying this, but it's true. Okay? So step one, detect. How can we detect? That's what this presentation is all about. Okay? Where did we come from? Well, I've developed this tool. Oh, shoot, I forgot that thing. No, I guess I'll just switch over to like, yeah, there's some sort of like thing in here, right? Go ahead, man. That's why he was late. See, he was looking up.
That's right.
Like on the way over, it's like, oh, shit, how do I do this thing? There we go. Oh, okay. Thank you. So a few years ago, like Frank was saying, I was supporting a brain-computer interface project called NEO, Neurally Enhanced Operator. And the idea was that they were going to take this quadriplegic, mostly quadriplegic, he was like three quarters. He had sort of use of one arm. And they surgically implanted a brain-computer interface directly in his brain. And it was duplex. And so we were able to control it back and forth. He could send signals, receive signals. We could simulate feelings in his body and on his fingertip that wasn't there before. He could control things on a computer screen while using his normal sensory things to do things in a multiplex parallelized mode. Here's a picture. That's a JavaFX visualization they asked me to build here for this. They asked me to simulate a cyber defense global scenario that could also be hooked into a brain-computer interface. So I did. That was in 2020. That was 4 years ago. It's old news, all right? And that's important because the money ran out. So I was like, oh, okay. So one of the things, why is this important? NEO, Neurally Enhanced Operator, was a success, but they were having some problems day to day. They had trained some decoders to decode the signals coming off these electrodes. There's something like 99 pins. So imagine like a vector of 99 signals, high, low, 0 to 1. They were analog, of course, but and every day they were finding that they would have to train their decoder and have this guy spend an hour to an hour and a half every day doing these different motions. They would capture the information. And then maybe the next day it sort of worked. And then like 2 days later, it wasn't really working well. And by 3 days, it was just way off. And what they found was the only reliable thing they could do was train it every day. But they only had this guy for 6 hours a day, 4 days a week. So they're spending 25 to 30% of their time with a one-of-a-kind resource. Just training decoders? But they're neuroscientists. They're using MATLAB. That's probably the problem. But they wouldn't listen to me. So I said, this can't be right. So I went and read some papers and got like some seedling money, like 10K, you know, just like, and what we did was I created a 3D viz that did some fancy vector math to see in the dimension reduction math to see like what are these signals actually looking like. And then I plotted them over time, and they created this really neat 3D loops in space. And what it turned out is that because they were training using a linear model, they were training on the same actions, but they were training on different rotations in space. So all the training data that each day they were training on was the same, but it was just kind of shifted a little bit in a subspace manner. Imagine if you had like in 3D space, you had some shape and it was just kind of like rotated. Still the same shape, but in other dimensionality, it's different. it's like in another dimension where I was like actually popular in high school and cool, right? Like technically I could have been, but all you see is the enormous dork that I am today. Fine. Wait, actually, that doesn't even fly anymore because the kids today nobody bullies. They don't get picked on. It's all in cyberspace. Like you can't. Everybody's happy and they hug each other in school. It makes me sick. Okay, so because I want the cycle of abuse to continue. So, they ran out of money. I ran out of money, and then a bunch of AI guys said, "Can you do that, but with really big vectors?" And I was like, yes, because I'm using Java. I'm like, okay, yeah, sure. And that's where we come to what can we do with a tool like Trinity, okay? So we took the thing that we built that showed the 3D vectors in 3D space after dimension reduction, we called it Trinity because, you know, Trinity in the matrix, right? Right. I work with so many kids that are like under 25. They're like, what is the matrix? And after I've bludgeoned them into unconsciousness, I like leave a DVD on their chest, which they can't play because they don't have DVD players.
Ask them about Forrest Gump. That's the only one that I found my students know.
Yeah, they kind of cherry pick, right? God help you if you make a Wizard of Oz reference. Okay, so LLMs. How does all this nonsense apply to LLMs? So let's say you have an LLM, a large language model, and it produces text. A large language model, and I'm guessing most folks in the room know this, so I'm not going to poll the room. A large language model represents its understanding of textual information as a vector. They call them embedding, something they call it token vectors. But at the end of the day, it's a BAV, B-A-V, big ass vector. Okay. So for example, ChatGPT is 1,536 or 3436. I forget the number exactly off the top of my head. 1536, right? It's a lot of dimensions. Okay. Now that's partially what makes it so damn effective. Okay. So let's say you're presented with a blob of text, and let's say that blob of text is a social media sized blob. Now, why that blob of text? I'll tell you why. Because people are impacted and affected by things that they consume rapidly. Okay? And remember that comment I made about how great and how terrible the internet is? That's where that comes into play. If we can generate content super fast, that's super realistic, and is consumable very quickly to the point where most people aren't even going to do any sort of like critical thinking about it. And Lord knows in America, we're getting a little short on critical thinking, right? But just like if there's not even a good reason to begin that process in the first place, you now have a propaganda factory that you can just turn the crank on. And the worst part is they can set it up where there's nobody even turning the damn crank. It's nobody at the wheel. It's those factories from Terminator where they're just pumping out the Arnold machines and they just go out and kill a bunch of people, right? I'm not saying ChatGPT is killing anybody yet. We're keeping an eye on it. So social media sized blurb, so we're talking like 3-4 sentences, let's say 4 or 5. That is the size, the critical sweet spot of size, where we would want to know if it's generated by a large language model, because we're going to want to know what type of messaging, what type of propaganda are bad people attempting to send. Like that message that he just got right now, that little. And so why not something longer? Well, anything that's long enough that gives a human time to pause. Hell, they might not even read the damn thing, right? That's not what the bad people are doing. Although there is a problem now with fake news and science papers being published. That's actually a really big problem in this globally right now. So that's a different issue. We're not worried about detecting whether or not it is generated by a large language model. We already know they are mostly, actually, sadly. We're trying to detect who's doing it. Another problem. Sorry, I shouldn't be sharing some of this stuff. So maybe I'll lose my job. I don't know. But you need to know these things. Okay, so I'm not the type of guy that reads slides. I'm the type of guy that makes slides without sleeping, and then I go and I like dotter off into these like sub statements. But if anybody has any questions about anything they see or I say, please raise your hand. Yeah. All right, there is not a dumb question. Okay, so the goal is make it, we got to be able to find an easy way to identify LLM generated text. We got to be able to do it in such a way that is practical and not overly expensive, okay? If you are trying to do it using the actual text itself, you lose. Why? Because the whole friggin' point is that they're designing these things so that you can't detect it. So up until now, at least up until last year, a lot of people have been like, oh, well, we're going to look at the word count, and we're going to look at phrasing to see if it's human-like. No, fools. The whole point is it's been trained to beat that. You lose if you're focused on the output. What you need to be focused on is the interior guts of the model, because that don't lie. And you know, another thing that doesn't lie is the math. What math? The vectors, the embedding vectors that represent the text. So here's a method. I call it masked perturbations. I've heard other people come back when I've shown this to people claim that they've seen it in published work as called probing. I am not a big fan of that word because I don't feel comfortable saying that at work. So I'm going to say masked perturbations. But
You do feel comfortable saying mass perturbations?
maybe we just call it masked probing and just get it over with, right? Okay, so like the picture says, what we're going to do is take the original text, this blob. We do not know if it's fake or not. The question is it fake? Okay, fake meaning generated by a large language model. That's actually critical. And let's assume that we're not trying to figure out which large language model. We're going to make an assumption, yay, verily, some large language model that we're hyper concerned about. And we'll just say ChatGPT synonymously as like with Kleenex or Xerox, okay? So you don't know that this blob is generated by an LLM. Here's what you do know. You know that if you were to remove every other word, or every third word, let's say, or every fourth word, or just randomly pick words, remove them, and then ask ChatGPT to fill in the blanks, you know 100% that whatever comes out of that is generated by the large language model, right? Right. So what we're going to do is we're going to use the large language model against itself, all right? What we're going to do is we're going to take a bunch of those perturbations and generate 40, 50 of them, maybe even 100 if you want to be certain, right? You know 100% that all 50 of those or 100 of those are generated by the large language model. And they're all a little bit different. And you got the vectors for all of them. What does that give you? A probability distribution. That's guaranteed. And now all you got to do is do a little simple vector math to see, well, how close is the original to this? If it's dead set in the middle, 99% sure that's generated by a large language model, right? Now you might be saying, but you can't be sure, right? Like, and how do you know? It's always going to be in the ballpark just simply because you based all the perturbations on it. It's like, well, yeah, I can't be sure. And I can't give you a definitive numeric answer that says because it's this number, it is fake. But what I can give you is a pretty good probabilistic threshold. Okay, and I can show it in 3D. We're going to visualize this data in Java and JavaFX. So I'm the last one, apparently. So here's an example of how this works, right? I wrote this last year, so yeah. So I didn't think it would be relevant again this year. So maybe I should get a new example just to avoid being political. But the idea is that we're going to take some chunk of thing and we're just going to say tokenize, like take out a few of them and we're going to fill it in, and then it generates some variations, right? They're all going to be in the ballpark, okay? And what we're testing mathematically, and actually, honestly, visually, is this hypothesis right here, okay? What we would expect is in any sort of probability distribution, whether it's mostly linear, it's Gaussian, whatever, it doesn't matter. You would expect the things that are most like each other to be bunched together, right? And the idea is that these should, all the ones you generated should be pretty darn close, and maybe there's like some long tailing, and the human one would be, or if it was generated by a human, it should be out on the edges somewhere. It's that simple. But wait, how do you get to that? Well, so and I'm going to demonstrate this. If I load the data into Trinity, Trinity has several 3D projections, starting with a hyperspace view. Everything's got to be hyper. I was very hyper as a child. I wasn't allowed to drink soda. I'm not allowed to drink soda now. My wife's in the back; she'll attest to that. I get out of control, but I can name my software hyper, and so we have a hyperspace view, and the hyperspace view is a scatter plot, but it's special because it understands data as vectors. And so when you say here's 1,000 vectors that have 1,536 dimensions, it says fine, I will plot this scatter plot using an arbitrary set of 3, 0, 1, and 2, and then you can flip around and reorganize instantaneously in 3D what combination of dimensions you want. But as you can see, that doesn't bias anything, because all this information you see from the colors, and this is just an example, it's all really clumped together. However, that's where the math comes in. Please raise your hand if you've heard of a mathematical process called UMAP. After this, go home and look it up, because it is your future. Okay? UMAP was produced in 2000, was first published in 2018, and with a secondary follow-up in 2019. UMAP stands for Uniform Manifold Approximation Projection. What is UMAP? UMAP is a nonlinear, fast, scalable dimension reduction technique that clusters data together based on similarity and can handle pretty much any width vector. The machine learning guys love it, right? It's PCA on steroids. It's TSNE on steroids. If you're still using PCA or TSNE to do dimension reduction, stop. There's a few corner cases, but there's virtually, just in the grand scheme of things, UMAP beats the pants off of those things on both performance and speed and memory consumption and scalability on almost all cases. Okay. All right. I'm off my soapbox, but there's an important point here. We built into Trinity a fast parallelized version of UMAP. And so what we do is we run the dimension reduction and similarity clustering algorithms on these big ass vectors, the BABs. So we go from 1536 for thousands of these instances down to 3. Okay. And that's what gives us these pretty groupings, where blue is human and red is ChatGPT. So tell me again why we can't detect ChatGPT-based text. Because I just did it 6, 7 months ago. And look, there's the same data, but I just used a different formula as part of UMAP. UMAP takes in a distance metric. Who here has heard of Euclidean distance? Just the point from point A to point B is that's a Euclidean distance. There's some guy named Euclid, and I don't think anybody liked him. He seems like, it's like if you're the guy who came up with distance, you're probably not fun at parties, right? Especially back then when like the parties were really focused on sheep or like mead, and what do you got to talk about? Well, there's these 2 points and I know how to, dude, Euclid. But there's other metrics, really any formula that will give you a sort of score between 2 vectors is valid here. And we built those into Trinity. And so what you see on the right is everything is the same, except instead of using a straight line distance, we're using a Yule metric, which is sort of like a true-false binary check to see if there's an agreement on the dimensions themselves. And now what you see is a hemispheric arrangement of the same data. Pretty badass. And finally, in that same space, so what? So what, Sean? You got a nice, pretty picture in 3D. Red is bad, except in Canada, and blue is good, right? But how do you know if something coming in based on your view is ChatGPT or not? Well, we also built in the ability to find a cluster automatically and then run a convex hull algorithm on it, which finds the outer hull of that in a 3-dimensional sense, which is an approximation of the manifold, i.e. the mathematical space of that information, that probability distribution, if you will. Then when you have another point, you just project it into the same system. It lands somewhere in that 3D space, and then you literally do it, back to Euclid, a Euclidean distance from where that point is to the nearest cluster. It's that simple at that point. You're using simplistic thresholding at that point. Is it inside the cluster? Is it inside that 3D shape? Well, it's probably part of that probability distribution. You don't have to look at numbers. Just look at where it landed, right? Is it outside but very close? Yeah, okay. How close? This close. Well, is this the threshold? I don't know. Now, that might be problem specific, and that's where you need a human in the loop. So the expectation is a human's going to take this approach and use tools like this and math like this in order to apply these methods, what I've been calling the volumetric projection method, because it's like there's volumes and you're projecting and then you measure distances. So I'm not good at naming things, but the point is you can apply it to anything, and that's the expectation, because there's never ever going to be a silver bullet method that's going to give you an answer to these types of problems, because the whole nature of these models is that they've been built from enormous resources to fool you and fool us and fool the math. But they can't beat math. They are math. So under the hood, this is what they are, and all we're doing is we're teasing it out, putting in a nice little 3D display so that we can see what we're talking about, and then giving enough knobs and dials so that a human can apply it to it. And if we've got time, I'll show you not only how this is applied to text, I'll show you how it's applied to deepfake audio and how we used it to detect the Joe Biden robocall in January, a month and a half before anybody else in the world. I did it in my spare time. I'm sorry. I thought you said this was hard stuff. It wasn't hard. It wasn't hard. Okay, so everything I've said so far, I'm going to show you. I'm going to click around, right? But this is a slide that sort of tries to capture all the adversarial questions that I would expect to receive from people in the audience. Unfortunately, nobody said anything so far. So either you agree with me wholeheartedly, or it's just a bunch of dullards, and that's fine. Whatever. As long as there's the hand. There it is. He's like, no. Now you're getting eviscerated. He said.
I have a question. So I use Microsoft tools, right?
Sure.
Outlook to write emails. And especially with the new version of Outlook, I noticed that, of course, they use Copilot, and it starts, offering you offering me completion of phrases.
Yeah.
And generally, okay, you probably notice I'm a foreigner, so not born in this country, so English not my native language. So it basically makes my emails more grammatically correct and whatever.
Which is good.
That's true. But how does it count against your model? Because technically speaking, whatever Microsoft uses in Copilot is probably LLVM, right?
Yeah. So this is a great question, and it speaks to practicality of using this and where do we sit with this type of research. The reality is, let's use your example. If you're using a Copilot-like tool, and let's say I know ahead of time that you're using a Copilot tool, and I know which Copilot tool. Let's just assume apples to apples. And then you hand me 2 chunks of email. One you wrote completely from scratch. And let's say you're having a good day and you wrote it with good grammatic things. You didn't misspell anything. And then the other one, you had Copilot assistance. You're saying assistance. You're not asking the Copilot to write the whole thing, right? Okay, so this is an interesting case because this is the future for this is now and the next couple of years. A lot of use cases for this stuff is going to be assisted, like assistance like this. So then the question is, how much of it is written by the Copilot, and is enough of it separated where we can chunk it? And so what this method would be able to do is say, let's say you wrote, I'm just throwing it out there, like 4 or 5 paragraphs, right? You wrote a long email, everybody hates you for it because they all want little short Slack messages because they're apparently don't have time to read. But what I would do is I would take that chunk, or that whole set of text, and I would try to chunk it at every sentence, every couple sentences, maybe. It kind of depends, maybe even at the paragraph level. And then I might even like break them up into different sizes and maybe 10, 12 things. And I would then take each one of those chunks and I would ask ChatGPT to give me a vector representation of that chunk. That's the original. And then B, what I would do is I would then do my perturbation thing on each one of those chunks. And I would generate so many perturbations. Now that number matters because the more perturbations you can create, the more accurate and likely your probability distribution will be, but that costs money. See, this is part of the unpractical part of this thing. Like every time, if I say, oh yeah, I'm just gonna, make a probability distribution and make 50 things. Well, you just used 50 ChatGPTs, their currency. You know what I mean? So, you got to pay for so many usages, right? We can dodge that because we host our own large language models internally, big ones too. And so I guess this works for us, and not for the peasants. I don't know. But that's how we would apply it to that type of problem. But a better question is not how, it's why. Like, what are you trying to get out of that? If you're trying to say, well, I want to know if somebody sends me an email, what parts of it were written by AI. Well, this is a method that I think you could apply that. But then it's like, what's your actual goal? If it's to weed out all the people that use AI so you can fire them, like, okay, well, I mean, sure, go ahead, terminate them. I don't care. But like I think there might be easier or better ways to accomplish that. So I'm always the first to say, before we apply these grandiose things, like stop and ask yourself what you're actually trying to do, because this is a big hammer. Okay. And this is appropriate for like, hey, is this group or organization or country trying to influence this election? And we have all these like messages, like, let's see, because that's the difference between World War III and not, maybe, let's say, so it's a big hammer, but for a big fucking nail. Can I say that word here? I did. Should I stop doing that, or?
We'll see.
Another question?
I think what I'm missing right now is once you're telling that UMAP and other preventive actions, but once we start getting to more GPT-6, GPT-7,
yep,
that means the RAGs are connected to your main large language model. Let's say you got inside large language models, but where are you extracting the data from? You know your side of extracting the data, but you really don't know what their side of the data is doing right now.
Yeah.
Right.
So this method, in order for this method to work in that situation, what you'd need to do is you'd have to generate these projections, these images I showed you, for each one of you would have to generate the vectors, the embedding vectors for all your different text globs and your perturbations, and you'd have to do it. You'd have to ask each version of the model to do it. You'd have to duplicate that. Because in other words, what I'm saying is, if I did all this work that you saw in the 3D stuff with ChatGPT, let's say 4, and then let's just say X comes out, like some X version, there's no way to know for sure if these projections will hold, and I would almost be assured that they would not. So you'd have to repeat that process, which is not fun to say.
But by the time you repeat the process, the model is capable of enough to challenge your models. That's what we are looking at, right? Next 365 days, like.
This approach and this exact approach with the way we're using the vector math technically offers to scale up. Because it doesn't depend on the quality of the output. It depends on the vectors that represent the output. So, for example, if you add more dimensions to your vector to make your model more effective, great. That actually makes this approach even better, because the more dimensions you give me, the easier it is for these dimension reduction techniques to pull these vectors apart and group them by how similar they are. Now, you may need more data. You may have to scale up how much data you suck in and then cluster together. That's okay. So, in other words, think about it like this. If you're trying to hit a target with some accuracy, right? And you say, well, I am 99% accurate. In a lot of cases, that's good enough, right? But in some cases, that ain't shit. 99.9 isn't anything. You ever heard of the Six Sigma or mission critical? Like five. Yeah, oh, you guys do finance. You know about getting fired if you fuck up. So like it's like 6 zeros. You need like 9s, right? But so like at the end of the day, if you are working on a precision that's that dense, then small changes are very noticeable. You'd have to have such a small perturbation that other people don't notice. Is this starting to make sense? So in other words, what I'm trying to say is, as models scale up in their capability, all they're doing is adding zeros in that analogy, which means that small little changes that had a major impact in today's models, those same changes don't have a strong impact, but they're very noticeable in the more comprehensive models. In the math, we'll see that like that, because it's floating point. It's just floating point math. You're just subtracting numbers at that point. I don't know if I think I might have screwed that up. I don't know if I explained that well.
But once the model will start getting deeper, things will start getting more chaotic for humans to intervene. I think I'm fine.
Yeah.
So if let's say right now you're looking to scale up the model, but once you start going the deeper inside the models, right? Let's say you got LLMs over here in BNY, and you got ChatGPT LLMs. But once you start writing a more deeper model for your asset allocations or risk or portfolio distributions or accounting frameworks and all, you can easily tweak that, because the regs or the models are learning on a daily basis. That's where the challenge will start coming up.
Oh, I see what you're saying. Okay, yeah. So there's an evolution that isn't going to be tracked well because we're looking at static snapshots. Yeah, now that's a good point, and that I have to admit, this is the end of the line of where we took this research at the end of last year and into this beginning of this year. So this is as far as that I've gotten, and I know there's some other folks that are probably thinking along those lines, but that's not me. So I don't have a good answer. But that right there is I would argue is
right. But a very strong foundation model that's in the model side of. We understand that exactly what is going to happen. And we will be absolutely government speaking. That's the only way.
Well, yeah, and my only counter argument would be, in defense of this method, if your foundation model that you're generating content with evolves, like you say, then go use the latest version to generate this stuff. But then there's a cost. Yeah. And so then you have to balance the cost of regenerating your clusters of information versus staying with the ones you've got, which you know are slowly but surely out of calibration. It's a calibration issue, I think, is what you're saying.
Yeah, I think that's a really good point. But yeah, I think you wanted to show a demo, right, Sean?
Yeah, and I know we don't have a lot of time.
Yeah.
So yeah, let me show you live what the screenshots we're sharing with you. Can we kill the lights in here? Is that possible, or is that a bad idea?
It's bad for the lights.
Well, let's get romantic. There we go. All right. So this is Trinity Tool Live. What's happening? Oh, you're just.
I don't know how to get back to my
you can't find your seat. Good luck.
I'm all right. I'm all right.
So let's load up the data. Ooh, the internal cover name was called nefarious usage. Scary, right? Okay, so what I'm going to do is load two data sets, two clusters of text. Okay, one set is human written. We basically gave them a prompt, a sentence, and we asked them to perturb that sentence. So like, write this sentence a bunch of times, right? And then we asked ChatGPT to do the same thing. Okay. So if we look at the ChatGPT one, okay, we're looking at the hyperspace view. Remember I told you we can switch between dimensions? Okay, I'm just flipping through indices. I'm just sliding the set. You can set them. You can set specific ones, but that doesn't help me because there's 1,536 dimensions. What good is that, right? The colors represent an auto coloring system that Trinity uses based on labeling, and the labels have to do with the sentence or the blurb that we asked the ChatGPT to rewrite. We go ahead and do the same version, but the human version. No, but do not clear the data nor the queue. We put it into the same space. You can see it just all gets glumpled together. It's not very useful. And remember, these are just 3 dimensions out of 1,500. So what we need to do is reduce this dimensionality. Okay. So in the same tool, right now we're in the hyperspace tool. There's a little guy, you know, warping. We're going to go to the projections view. Okay. Right. It's called projections view because you can generate manifolds using tools like UMAP, for example. So looking at this, there are, each one of these is a variable, a parameter that UMAP can and will support as part of its process of doing this, the dimension reduction, the gradient descents, the separation. And making small changes to these variables will have nonlinear effects to the result. That's both a blessing and a curse. The blessing, because this gives us an almost infinite freedom of solution space to search for as a human. It's a curse because where the hell do we even begin? Now, I don't have a very good answer for that. The best answer I've come up with is this right here. I made it just run fast as hell, and I made a whiz-bang, slick little wizard-type GUI, so I could just sit there all week and be like, I'm going to try this setting now. And I just kept doing the duhs until things started to land. And then you start to get a feel for, I just dragged and dropped some settings. Notice these bars moved around a little bit. Okay, I'm going to run this thing. I'm going to watch a little TV while it runs. Do we have sound? Oh, now the sound's not working. All right. So I built into Trinity this ability to play retro commercials while you wait for math processes. This is old Atari commercials. I also got like TV spots for like old sci-fi movies like Terminator 1 and Mad Max. All the things that I knew were out there when I was a kid, but I wasn't allowed to watch. Okay, so look at this. Look at this. So Trinity running UMAP. So it's really UMAP. And these exact settings just took this hyperspace glob data, reduced it down to 3 dimensions, and then pulled these things apart. And then, watch this. This is a coloration settings where anything that has the label of human will be blue, and anything that's ChatGPT red. Did I just blow up? Hold on, let me double check something. Oh, yeah. I'm sorry, guys. It's been a while since I walked through exactly. There you go. There's the red and the blue space, but you notice it's still interwoven. These things aren't separated yet. But in this projected space, where the projection is based on similarity, they are very separated. And that gives you that beautiful screenshot that we were talking about before. Turn this off. Turn off that. Okay, now if we look closely, see this guy here? That's the original one. That's the text right there. Okay, that is the original text for that particular glob. Okay, and then one of these are one of the perturbations. And even look to see what the differences are. You'll probably notice there's like 1 or 2 words change, that sort of thing. You don't have to read it. You get the point. That's the point of this tool. So actually, this kind of gets us to the head of why we had this session. It wasn't for me to sit there and bemoan the death of the internet and bemoan how we're all sliding chaotically like lemmings to our information doom. It's actually, this is a Java tool in JavaFX visualization, a little Java visualization for you, that is solving the problem of detecting AI-generated fake information. So in other words, we Java developers don't necessarily have to be whiz-bang Python guys who are cheating just using C, but they won't admit it, and to train all their models. You can also provide analysis tools. And let me be very clear. How many people are going to be training AI models in the future? No. Sorry, put your hands down. That was rhetorical. What I meant is, I'm skeptical as to whether or not that's even going to be a significant job for much longer. Think about it. They're commodities, model zoos. Just go get one. And right now, what are all the people who are training models doing? They're pulling down models from model zoos and they're fine tuning them. Now, not the big boys. There's some big boys and big girls out there that are doing some real training, right? But in order for models to be effective at that level, they need enormous resources. We are a federally aligned lab with 10,000 employees, and we've been around since World War II. And we're the biggest of our kind, nonprofit. By the way, I'm not trying to sell you a product here, but we're nonprofit. I don't care. This is on GitHub. You can have it. It's yours. Best AI analysis tool that's ever been made. It's yours. TensorBoard, see you. Goodbye. You're terrible. No good. Although they have this nice labeling feature that I don't have. Like I have labels, but like you can set it up where you like hover over an area and it shows you only the labels, but only it for those points nearby. That's nice. That's a nice little feature. That's it. The point is, we can barely afford to do this. I mean, we're spending millions, tens of millions of dollars bringing in like DJX farms and that sort of thing to support our federal government sponsors and their needs. And like, how many people are going to be doing that in the next few years? I guess what I'm trying to say is what's really going to happen is there's going to be a bunch of people who are going to try to find a way to take those models and allow you to make quick little easy tweaks to them to fit your needs. That's going to be the new niche. That's going to be the big job area, I think, in about 5 years. And you're going to need tools like this to help explain whether or not you're tuning it well, whether it's being applied to your problem properly, that sort of thing. So as Java developers, we can and should be taking the lead role in the AI world over the next 4 to 5 years. But we just got to understand where our role is. We might not be Michael Jordan, but we can damn well be Dennis Rodman and get those boards. Wait, this is New York. We're not in Chicago. Who's a good player for the Knicks? Nobody. Okay. All right. All right. I think I'm out of time. Is that true? Another 5 more minutes. Okay. 5 more minutes. You guys, you get it, right? Like we got clusters. That's fun. Hey, respond. There you go. Okay. So let's clear this. How can we apply this to audio? Let's hope didn't use up all my video memory. Who remembers the Joseph Biden robocall deepfake in January? Raise your hand. Yeah. Okay. So that means the 5 or so people raised their hand. So there was a deepfake robocall that was made, as in somebody used AI to fake Joseph Biden's voice, and then they used that fake. They generated a fake phone call that was a robocall, and then they sent it out automatically to thousands and thousands of Delaware voters, telling them not to vote. Doesn't this sound bad? This sounds bad, right? Like this is not a good thing. Everybody's kind of like, yeah, so what? Fuck it, you know? Fuck Delaware, you know? And as a Marylander, I understand that sentiment. But it's not good, right? That was at January 24th, I want to say. And the first reports I saw that were unclassified about where they finally figured out who, like, that it was in fact a fake. They proved it was a fake, and then who did it didn't come out until March. Partly because I didn't release my findings. But the point is, you can use tools in this method to do that. Here's how. Quick run through. We're just going to demonstrate. Okay. Okay, Biden deepfake. I'm going to try the sound again because if we can't hear it, then it doesn't help, right? So here is.
Is your audio muted completely, or?
No, it's not muted at all. But maybe it says this Crestron high dip. Maybe I got the wrong device. Maybe I don't know. I'll try it one more time. We're going to play the actual call. This worked at the beginning. Well, folks, forget it. Maybe on Zoom it's just like pouring in, right?
I don't, it couldn't be a Zoom problem. I pick a different,
Yeah, it's on Zoom, but I didn't join Zoom with audio. I didn't think that mattered. Maybe it does, right? I'll try to play it on my speakers.
yeah,
Maybe hear it, right?
yeah.
All right, here is the fake. Can you hear that?
Turn up the volume.
It's up all the way.
The mic doesn't. Oh, here, yeah, put,
Yeah.
oh, here.
Well, sorry, it's
Yeah.
it's okay. I even brought a wireless speaker, but we're out of time. Here's the point. It friggin' sounds like Biden, right? But then what they did was they ran it through very standard audio processes to reduce the quality a little bit. Makes it harder to hear the inconsistencies. These are easy, time-old tricks, man. And it worked. It worked for thousands of people. This is the problem. It doesn't matter how I have friends that are like, you can't get me. I can tell the difference. First of all, you're wrong. It's already happened to you. You just don't realize it. But even if that were true, it's not the one. It's the many, the horde, the Zerg rush of morons. And in America, we got a big herd, right? And they don't have to get all of them. They just have to get enough to make a difference, to move the needle. And it's so cheap to do it that it's no problem. So what does solving this problem in this manner look like? Oops, my bad. Okay. So here is the data itself. What do you mean data? So what I did was I took all 32 seconds of it, chunked it up into 2-second chunks. Okay. Oh, Sean. Yeah. And I took a bunch of real audio clips that were labeled real that are verified. Trust me, I don't have time to explain that. And some fake ones that were for human voices that were also verified to be fake. We have access to databases of that. About 20,000 of each. I loaded those in, and then I ran my UMAP tool on it. Okay. I want to watch TV so bad, but without the sound, it's just painful. This takes about 40 seconds because now we're dealing with tens of thousands of big points. What does this mean? What do you mean I took a bunch of vectors? I took, for each audio chunk, we ran it through a foundation model called Wave LM. So it's like for sound, what ChatGPT is for text. And we said, give me a vector that represents this audio. Very good at that for human type stuff, right? Now I've got vectors for all these audio chunks. Now you got these different colors, right? And let's see, what's our color scheme? Oh Lord, I've got so many different ones. I should have cleared it. Clear all, rescan. There, we got 2. So blue is fake. Goldish, bronzish is real. Okay, remember that. Look at this, all right? Okay, now then. Almost done. Thank you for being patient. Now then, this little guy is going to help us project. He's now freezing the math, the transformation matrix, technically speaking. But we're freezing this projection of data that we know is fake and real. It's been colorized based on the label. Then we're going to take the Biden stuff right here. That's these guys. Let me make sure I got the right one. Yeah, there we go. We're going to drag that in. Animate the projections. Drag it in again so you get to see it. There they are. Usually when I have 2 monitors, it's easier. You saw a bunch of things flying around, right? Yeah. Over here. Change the color. Right there. See this? Biden deep fakes. Over in this cluster over here, where you have the human, known human ones, and you have the blue, you have the spoof ones that are designed explicitly to represent and fake the human ones. You get all the Biden stuff, and it all lands right on the ass end of all the fake ones. What does that mean? That means from a probabilistic standpoint, it is highly likely that they are also fake. And it's pretty obvious because they're all, like, out of 17 total clips, 15 or 16 of them, I forget the exact number, are all clustered together, all on the fake side of a common cluster. Is this the most rigorous way to prove it? No, but I did it in a weekend, so, you know. Okay, I can't emphasize enough how easy this was now that the tooling has been built up. And here's the other cool part. And I'll end with this, and questions. If we hide the other colors, look at that. There are a few that are not. That tend to also be in spoof or on bona fide. And these ones right here are the bona fide ones, I believe. And I can't play the sound. Crap. But the ones that are aligned closest with an isolated real bona fide, they're the ones where it's Biden's catchphrases. What a bunch of malarkey. This and that. I forget the other one. In other words, the other sneaky trick that these guys did was they didn't ask the AI to fake the entire thing. They asked it to fake the majority of it, and then they took actual clips and spliced them in to further make it more difficult for detection models because it was actually real. These detection models, the current way that people are trying to solve this problem is by training big ass deep learning models to just say, yeah, that's fake or that's real. And that's fragile. It works and it's fast once you have it trained, but it has a huge upfront cost and it's very brittle because it isn't able to pull these things apart. That's not how it works. It's an all or nothing snapshot. This method pulls these things apart. And it gives you that sort of insight, but it's never going to be effective without a human in the loop. And so in conclusion, it's tools like this that are going to accelerate human-based AI analysis. And again, that's why Java is important over the next 4 to 5 years. And that's why you need to keep coming to this meeting and bring $5 and friggin' pay for your damn entry fee so you can have people better than me actually give better presentations. Are there any questions? I'm sorry we didn't get to play asteroids.
Do we have time for questions?
One question.
One
Sure.
question.
You can get this on GitHub, folks. I cannot tell you enough how free this is.
This also through video.
Oh man. Okay. So
You apply to video.
I'm working on that now, and I can't talk about it.
All right, then don't answer.
But I can tell you from
If you have to kill us, then don't tell us.
No, anything like that. They'll just kill me. No, from a generality standpoint, I've demonstrated text and audio, imagery. You work on the pixels. I do have a demo for that, but there's no time. But with video, the general secret is you don't work on the pixels of the frames. You work on the changes of the pixels over time. Okay.
Frame. It's actually pulsing, not streaming. Frame to frame.
Right.
And the changes.
Right. And the solution is a signal processing one. Look ye young man to FFTs. Look at the frequency changes of the luminosity. That'll give you your answer.
All right. Thanks again,
I'm
John.
sorry.
No, thanks again. All right. Thanks to Sean and Andrews and to everybody out on the internet. We'll see you next time.